Hello, this is section 7.4, confidence intervals for the variance and standard deviations. Okay, so the previous ones we are using the proportions, and this one we are using the variance and standard deviations. Mostly we are using the standard deviation. So find a confidence interval for the variance and standard deviation. In manufacturing, it is important that the product dimensions are consistent so that they will fit together, or that the amount of the active ingredient in a medication have a little variation so that it delivers the correct dosage. Thus, the confidence intervals for the variances and standard deviations are necessary. So, new distribution called the chi-square distribution is used. The characteristic of the chi-square distribution, so all chi-square value are greater than or equal to 0. And then the chi-square distribution is a family of curve based on the degree of freedom, just like a t-distribution. And then number 3, the area under the chi-square distribution is equal to 1. And then chi-square distributions are always positive skewed, okay, which is a right squared, which means we call the right skewed. All right, so this one. Okay, so to find the critical value of the chi-square, use the table G. Table G in appendix A. You need to know the degree of freedom, which is n-1, the confidence in the level, and the value of alpha. For instance, for the confidence level, which shows a 98, which is alpha equal to 1 minus 0.98, which is 0.02. And then locate the degree of freedom in the left-hand column of the table G, and the values for the alpha over 2 and 1 minus alpha over 2 in the top row. The value of the chi-square left is the row corresponding to the degrees of the freedom, and the column corresponding to the 1 minus alpha over 2. The degree of alpha chi-squared right is in the row corresponding to the degree of the freedom, and column corresponding to the alpha over 2. So if the number of the degree of freedom not given in the table, use the closest to the lower value in the table. All right, so this is actually the chi-square table distribution. So this is the number of the degree, and this is actually the percentage we get to here. So find the chi-square left and the chi-square right from the problem we have. So first of all, before we do that, we need to find out the degree of freedom, which is n-1, which is 6 minus 1, which is a 5. Okay, so that's what it is. And then we need to find the alpha over 2, which is 0.05 over 2, which is 0.025. And also 1 minus alpha over 2, which is 1 minus 0.025, which is 0.975. Okay, so chi-square 1 minus alpha over 2, which is chi-square 1 minus 0.025, which is chi-square 0.975, commodus. Okay, so the degree of 5. So we need to see the degree from here. So degree of 5. And then we have to have a 0.975. 0.975, which is this one. So you'll see the 0.831. And then chi-square right, which is chi-square alpha over 2, which is chi-square alpha over 2 is 0.025. So same the degree of freedom. Now this times it's going to be 0.025. So this is the number. So you'll see as 12.833. So these two numbers, okay, we're using. All right, let's try one more. So degree of freedom, which is 19 minus 1, which is 18 this time. And then alpha over 2, which is alpha is 0.02 over 2, which is 0.01. And 1 minus alpha over 2, which is 1 minus 0.01, same as 0.99. Then now we can find the chi-square left, which is chi-square 1 minus alpha over 2, which is chi square 0.99. So this time is a degree of 18. So degree of 18, and then we are using the 0.99, which is right here. So this becomes 7.015, and then chi square, right? Which is chi square alpha over 2, which is chi square 0.01, so 0.01 right here, and then it becomes, yeah, this numbers 34.805. Okay, so we will use this one. Alrighty, so now formula for the confidence interval for variance. Okay, so this is the formula. Okay, so this is the formula with the confidence interval with the degree of freedom. And then also when you confidence interval, but there was a variance, but this is standard deviation, so this is the formula. And assumption for the finding a confidence interval for a variance or standard deviation must be the random sample and normally distributed. So when computing a confidence interval for the population variance or standard deviation using raw data, round up to one more decimal place than the number of the decimal places in the original data. However, you are using sample statistics, round up to the same number of the decimal places as given for the sample variance or sample standard deviation. Alrighty, so let's take a look at the problem. So in the problem, we have a data, okay? So length of the children's animated films. The length in minute of the random selection of the popular children's animated films are listed below. Assume the variable is normally distributed. Estimate the population variance and division in length of the children animated film with a 99% confidence. So, in order to find the variance, so there is a formula for the variance, okay? So, the variance formula is, okay, so you have to find the sigma x sub I square minus sigma x sub I squared divided by n over n minus 1. Okay, so if you do this, okay, so if you do the x sub I square, means you need to square up each of the data value and then add them all together. And then for this one means you need to adding all the data value and then add them together and then square them. And then divide by n, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equal to 11. So which is 72.055. So this is what I got, which is we call the S square. And degree of freedom was n minus 1. So 11 minus 1 is 10. Alpha is 99%, so 1.0.99, which is 0.01. And also alpha over 2 is 0.01 divided by 2, which is 0.005. And then 1 minus alpha over 2 is 1 minus 0.005, which is 0.995. Okay. And then chi square left, which is, if you use a table, okay, I get 2.1546. And then chi square right is the 25.188. So, but I'm using the square root to find the standard deviation over and then sigma, and then n minus 1 s square over chi square left. Okay, plug it in. So 10 minus 1 is the n minus 1 is the 10 times s is 72.055. Square root of chi square right is 25.188. And then sigma n minus 110 is s squared, the same as 72.055 over chi square left is 2.1546. And then simplify, I get 5.349 sigma and 18.281. Okay, so that's the confidence intervals for with a 99% confidence. All right, lifetime of wrist watches. Find the 90% confidence intervals for the variance, standard deviation for the lifetimes of inexpensive wrist watches. If a random sample of the 24 watches has a standard deviation of 4.8 months, assume the variable is normally distributed. Do you believe that the lifetime are relatively consistent? Why or why not? Okay. So in this time, S squared is already given as a standard deviation 4.8 squared, come out as 23.04. And also degree of freedom, which is any minus 1. So n is 24, subtract 1, become 23. And the alpha is a 90% confidence interval, so 1 minus 0.90, which is 0.10. And then alpha over 2 is 0.05. And 1 minus alpha over 2 is 0.95. Chi square left, which is chi square 1 minus alpha over 2, chi square 0.95, which is 13.091, chi square right, which is chi square alpha over 2, so chi square 0.05, which is 35.172. So in order to find the confidence interval, n minus 1 s squared over chi square right between the sigma n minus 1 s squared over chi square left. And plug in the number, I got 23 times 23.04 over 2. The alpha, you got 23 of 23.04 over 35, sorry. It's got to be the chi square left. So 13.091. And then when you compute inside, you got the 15.067 in the radical sigma. And also this come out as a 40.480, which is 3.882. That sigma is 6.362. So this is actually the confidence interval. So this could be a yes or no, because the lifetime are or are not relatively consistent, because the answer vary. Possible response might be the yes, because the lifetime vary between about 4 to 6 months, or no, because the lifetime vary more than a month for this case. Okay. All right. Thank you for listening.